Hey there, welcome to this video on solving right triangles in context. We're going to go ahead and look at some contextual situations, and we're going to apply our knowledge of how to solve right triangles to the situation in order to solve the word problems. Our objective is just that, solve right triangle problems in context. Prior knowledge, if you had to find the measure of angle B, what is it? Round to the nearest degree. Well, a reminder, here's B. And they give us the side that is opposite and the side that is adjacent. So that is going to be tan of B is equal to 13 over 4.8. Now this is an angle, so we're going to go ahead and use tan inverse of 13 over 4.8. Alright, so we'll go ahead and calculate that here. Tan inverse of 13 divided by 4.8, and we get approximately 70 degrees. 70 degrees. Okay. So this is what we're going to be doing today, but in context. We're going to be looking at some contextual situations. And here are some general steps that we can go ahead and apply to these problems. Step 1, draw and or label a diagram with all given information. Pictures help so much, right? How many words are they worth? 1,000. That's the phrase. And we can just label them and go ahead and plug in information that's given, and then also help us to figure out what we're solving for, what we might have to do. Number 2, determine what measure of the triangle needs to be found. So what are you actually solving for? That's important to know. And then step 3, go ahead and solve. Do you need to use inverse trig? Do you need to use a trig function? Do you need to use Pythagorean theorem? One of the steps that we've been using will be applied. Again, here's just a reminder about SOHCAHTOA. If you are solving for a portion of a triangle, and you're given information about a side opposite or adjacent or hypotenuse, you're going to use these trig functions for these ratios, okay? And if you ever forget again, right next to me, SOHCAHTOA on the board, and you can write it down to kind of help you remember. If we're solving for an angle, again, we'll use the inverse trig. Inverse trig is used to solve for an angle. Okay, so let's go ahead and look at our first example here. And they say a drawbridge at the entrance of an ancient castle is raised and lowered by a pair of chains. The figure represents the drawbridge when lowered. Find the measure of the angle to the nearest degree the chain makes with the drawbridge. Okay, and so they give us some information here, and I'm just going to kind of highlight so you can be oriented to this. So they say a drawbridge is raised and lowered by a pair of chains. So here's the chain. They tell us this in the diagram. Okay, and they're saying, hey, the length of the chain is 5 meters. Now we have a wall here, and the drawbridge is here, which they say is 3.2. So here's the drawbridge. Okay, what do they want us to find? They say find the measure of the angle. So we're solving for an angle to the nearest degree the chain makes with the drawbridge. So here's the chain again. Here's the drawbridge. So we want this angle. We want angle A. If they had said find the angle the chain makes with the wall, that would be up here. But they don't say that. So I don't want that. Okay. Well, in order to find this angle, I need to use a trig function. So looking at the information given, the side opposite is the wall, the side adjacent is the drawbridge, and then the hypotenuse is the chain. So I'm just labeling those. And if I want to go ahead and find this, it looks like I have to use information about adjacent and hypotenuse. Okay, so again, SOHCAHTOA. If you don't have it memorized or know automatically, you can just write that down. SOHCAHTOA. And adjacent hypotenuse, that's going to be cosine. Okay, so cosine of angle A is equal to adjacent 3.2 over the hypotenuse, which is 5.0. Okay, and since I want to solve for an angle, I'm going to use the inverse trig function now. So A is equal to cosine inverse of this angle, 3.2 over 5.0. So we'll go ahead and plug this in. Okay, so cosine inverse, I gotta find that. Okay, so cosine inverse, 3.2 divided by 5. And it looks like we get 50 degrees. So this is approximately 50. Okay, so we can answer their question. We say the angle, the chain makes with the drawbridge is about 50 degrees. Okay, this is a word problem, so generally you answer in a sentence, in words. Okay, all right, here is a practice problem. Please go ahead and pause the video, and then I'll show the solution here in a second. Okay, hopefully you went ahead and tried to solve this one. They say a shelf extends perpendicularly 7 inches, so this distance here is 7 inches. And then you would want to place a 9-inch brace under the shelf. So this distance here, this is 9 inches. 9 inches. Okay, they say to the nearest degree, what angle will the brace make with the wall? Brace is here, wall is here, that's this angle. Angle B. Okay, so your equation, it should have been opposite over hypotenuse, so sine of B is equal to 7 over 9, and then you could use the inverse. So here is the solution. And you would get about 51 degrees. The brace makes an angle of about 51 degrees with the wall. All right, next example. Here, these problems are going to get a little bit more tricky, so pictures are going to be really, really important, okay? In this example, they say a ladder on top of a fire truck is fully extended to reach the roof of a burning building that is 50 feet tall. Okay, so the building that's burning, a burning building, is 50 feet tall. So this distance here is 50. Here's 50. Okay, how long is the ladder to the nearest tenth of a foot? Well, I want to find out how long is the ladder to the nearest tenth of a foot. So here's my ladder, this distance here. Okay, and then they tell us, hey, this angle is 65 degrees. And I need to go ahead and solve this. Something that's probably omitted actually initially is this information here. This usually isn't given. And they tell us, hey, the fire truck is 10 feet tall. So then solve this triangle. Well, in order to solve the triangle, I need another piece of information. I know that the angle here is 65 degrees. I want to solve for the hypotenuse, but I don't have any other information. Well, by them telling us that the fire truck is 10 feet, this distance here, I guess for this portion of the building, is going to be 50. Take away the height of the truck, which is 10. So that's how we get 40 feet here. So that distance is 40 feet tall. Okay, well, if I want to go ahead and solve, I am given information about the side opposite, and I'm solving for hypotenuse, so this is a trig sine function. So sine of 65 is equal to 40 over x. So there's my equation, and I'm going to go ahead and solve this. I'm just going to multiply each side by x, multiply by x. So we get x sine of 65 is equal to 40. We'll divide both sides by sine of 65. And we'll get x is equal to 40 over sine of 65. So we'll go ahead and we'll plug this in. So we get 40 divided by sine of 65, and that's approximately 44.1. So they say to the nearest tenth of a foot, so approximately 44.1. Okay, and again, we want to answer with a sentence conclusion. So the ladder is about 44.1 feet long. Okay. All right, here is a practice problem. Please pause the video, try this one. This one can be tricky, so if you're really stuck, I'll go over the placement, but make sure you at least try to place the information that's given. All right, here is the information place. They tell us the two buildings are 80 feet apart, so this distance is 80, which means that this distance, the adjacent side on my hypotenuse, is also 80. They also say if the shorter building is 45 feet tall. Okay, so this building is 45 feet tall. They say find the height of the taller building. Well, if this distance here is 45, right, that's the height of this building, then that means that this distance is 45 and this distance is 45. So really what I need to find, if I know that that's 45, is I need to figure out, okay, what's this distance? What's the distance from the top of the building to there? And that's the side opposite. Okay, pause the video. If that helped you out, go ahead and find out how tall the building is to the nearest foot, tenth of a foot. Okay, hopefully you solved this. Your trig function should have been tan 38 is equal to x over 80, which means that x is 80 tan 38. Now this will only give you part of the building, 62.5 feet. You need to add that to the original 45, so the total height of the building is 107.5 feet, 107.5 feet. All right. Lights went out. Good thing I have my Christmas lights behind me. Okay. Here is the last example that I have for you. And they give us some information. They say an 8-foot stop sign casts a 3-foot shadow. Nearby is a tree that is 15 feet tall. How far from the base of the tree is the stop sign? Round to the nearest tenth of a foot. All right, so they give us some information. They say, hey, the stop sign here, that's 8 feet. It casts a 3-foot shadow, so that is given here. All right, and then they say nearby is a 15-foot tall tree. Okay, so this tree is 15 feet tall. They want to know how far from the base of the tree is the stop sign. So how far from the base of the tree is the stop sign? So here's the base of the tree. That's this distance right there, x. Okay, well, what I can do is I can use some right triangle trigonometry. If I know that this is 69 degrees, I have the side that's opposite. I want to find something about the adjacent side. So tan of 69 is equal to 15 over what I'll call y. And I'll say that y is this whole distance. It's x plus 3. So y is this whole distance. Okay, well, solving this, I'm going to go ahead and multiply both sides by y. So y tan 69 is equal to 15. And then we'll go ahead, we'll divide both sides by tangent of 69. And we get y is equal to 15 tan Not 169, just 69. Okay. So, let's go ahead and see what this is. Let's plug this into our calculator. $15 divided by tangent of 69, and we get 5.8. So 5.8 is what y is approximately. 5.8 feet. Okay. Well, I mean, that includes the whole side, the whole entire side. So what I need to do is I need to go ahead and subtract 3 from this, right? So 5.8 is equal to 3 plus x. So solving for x, we get 5.8, and I'm subtracting 3 on both sides. Okay? So this gives us approximately 2.8 feet. That's how far the base of the tree is from the stop sign. Okay, and we'll want to write that in a sentence conclusion. So we'll say the base of the tree is about 2.8 feet from the stop sign. Okay, a lot of people get confused on how do I write my sentence? I don't feel comfortable writing this sentence. I don't know how to phrase my answer. Well, you can phrase it based upon the question posed. So in the question they say, how far from the base of the tree is the stop sign? And actually, well, I kind of flipped my words here, but I just copied it. The base of the tree is about 2.8 feet from the stop sign. So just use the question to help you out. All right, here is the last problem. It's a practice problem. Go ahead and give this one a go. All right, hopefully you paused it. In this example, they tell you a person's 6 feet tall. So here's 6, standing 20 feet from the base of a street light, casts a 10-foot shadow. What is the height of the street light? They want this. Well, an issue with this one, I don't know if you picked up on it, is that we're missing this angle here. I need this angle. So how can I find that angle? Well, they do give me a smaller triangle here. They say that this guy is 10 feet, or he casts a 10-foot shadow, and he's 6 feet tall. And then you go ahead and find this angle. So I can use inverse trig. This is tan of x is equal to 6 over 10. So x is equal to tan inverse of 6 over 10. So computing this, we get tan inverse of 6 divided by 10. We get about 31 degrees. So this is approximately 31 degrees. So right here, 31 degrees. Okay, so pause the video if you did not solve the original equation, or the original question. They say, what's the height of the street light? So you should have enough information now. Go ahead and give it one more go. Okay, hopefully you paused the video and tried it. The triangle, they tell us this side's 30, and I want to solve this side, and that angle is 31 degrees, right? 20 plus 10, that's going to be 30. And you can use that to help you find that the height of the streetlight is about 18 feet. All right, in this video, we solved right triangle problems in context. Go ahead, if you like this video, give it a thumbs up. Subscribe for more awesome math content. Catch you next time. Peace.